Good day, each and everyone. Thank you for joining us today as I present our study with my co-author, Dr. Ninita I. Prado, which entitled Exploring Data Visualization for Effective Communication and Decision-Making Efficiency in the Planning Design Office. To introduce myself, my name is Geneva G. Villamor, and I am currently working as a civil engineer affiliated with the Department of Public Works and Highways, Regional Office 10. Currently, I am designated as the Assistant Chief of Staff of the Office of the Regional Director, and I graduated my master's degree in engineering at the Kanazawa University in Japan. Here is the outline of my presentation. So the DPWH, as the primary engineering and construction arm of the government in the Philippines, this faces challenges in managing large-scale national infrastructure projects. This agency, where I belong, communicates with diverse stakeholders. So this study aimed to address these challenges by exploring the transformative potential of data visualization within the DPWH Planning Design Office. Why I chose Planning Design Office? This is because in our process model in DPWH, everything starts with the planning. This research integrated key theories and concepts as follows. We have information processing theory, cognitive load theory, communication accommodation theory, communication ecosystem infrastructure planning, and data visualization as transformative tool. These theories and concepts help us understand how stakeholders such as DPWH interpret project data and process information, showing how clearer and well-designed graphics or data displays can support better decision-making and guiding more effective communication strategies. The study assessed the utilization of data visualization, generally aiming to enhance communication strategies and improve decision-making efficiency within the context of planning and design processes in the DPWH Region 10 Planning and Design Offices. This study also specifically aimed first to determine the level of all variables, each with different sub-variables. So we can see on the other side the list of independent and dependent variables. Also, it specifically aimed to determine the significant correlation relationship between these factors to identify which variables best influence overall performance, and lastly, to develop a structural model that best represented these relationships. So the research was set within DPWH in Region 10. The figure 1 shows the map of Region 10. The study also involved a total of 209 planning design staff, which includes engineers, architects, and other staff from the planning design offices of the regional office and across 14 district engineering offices in Region 10. The survey was conducted last year around April to May 2024. This study employed a descriptive correlational research design, which provided the current state and levels of all the variables, computing the mean, the standard deviation, as well as the correlation. Lastly, the use of path analysis guided by a causal model was also applied to construct a predictive structural equation model. The research study employed self-made descriptive survey questionnaires with a design 5-point Likert scale. Pilot testing, reliability, and validity tests were done before the final survey. And of course, stratified random sampling method was applied. For the results and discussion, the results in the graph for the first variable show that there is a moderately high level of experience and engagement with data visualization techniques with a mean score of 3.45. However, with a moderately high level, there is still a room for improvement in areas like staying informed and fostering deeper collaboration. This also indicates that increasing awareness of trends and advancements could further enhance engagement. The second variable, which is the organizational culture and support for data visualization with moderately high level, has a mean score of 3.25. However, there is still a room for improvement about satisfaction levels and strengthen the cultural foundation. This also indicates that leadership should promote data visualization and innovation. The third variable, which is the importance of visual design elements with the overall level of high compared to the other variables, with a mean score of 4.13, this highlights the significance of typography and iconography in creating effective data visualization. This also highlights the need for the organizations to prioritize design consistency and clarity in their visual strategies. The fourth statement of the problem analyzed the fourth variable, which is the complexity of visualization, which has a moderately high level with a mean score of 3.39. The study also found that participants generally agree that complex visualization can enhance data understanding, but also recognize the challenges associated with managing and interpreting such complexity. The fifth statement of the problem revealed that employees have a moderately high level of integration of data visualization with other communication channels with a mean score of 3.59. However, there is a room for improvement, particularly in accessibility and training on advanced tools. This also suggests the need for the organization to adopt multimodal communication strategies that leverage data visualization across platforms for effective communication. The sixth statement of the problem examined the overall performance with a moderately high level of a mean score of 3.43. So the study found that communication effectiveness was more effective subvariable in which the decision-making efficiency was rated slightly lower. So this result suggests that the Planning and Design Office is meeting expectations, but there are still areas for improvement. Therefore, strengthening decision-making processes and refining communication strategies could enhance the efficiency and overall performance. So for the correlation analysis, the results found that employees who are more engaged and experienced in using data visualization contribute to overall performance. However, the basic training and experience in these techniques did not significantly influence performance. A strong organizational culture and support with the sub-variables are also crucial factors. Visual design elements such as typography and layout improve overall communication, while color and contrast have no significant effect. Complexity of visualization did not significantly impact performance, while integration of data visualization with other communication channels positively correlated with performance. For the multiple linear regression analysis, as shown in the table, revealed that several factors such as organizational culture and support, visual design elements, and the complexity of visualization significantly influenced the overall performance. For the path analysis, there were four structural models postulated, tested, and validated using the structural equation approach to find the best fitting model. So these are the first three models postulated. However, the model 4, which is called the Villamor's model in data visualization, was found to be the best fitting model given the values in the table shown where all the standard indices met the criteria. The study suggests several recommendations to improve the overall performance. First recommendation is to adopt Villamor's model. So this model can help various offices such as DPWH create data presentations, improve analytical insights, and foster a data-driven decision-making culture. The second recommendation is to increase employee engagement and proficiency in data visualization tools by providing specialized training programs, not just the basic training, on visualization tools and techniques which can encourage deeper collaboration and better understanding of industry trends. The third recommendation is to strengthen the organizational culture around data visualization through leadership engagement and resource allocation. The fourth recommendation is to prioritize the development of advanced data visualization skills for the head of offices, such as the regional director and district engineers, by emphasizing clarity in every visual presentation and simplifying complex visualizations. This can lead to a better decision making. Finally, for future researchers, expanding research to other regions or other organizations such as Department of Transportation and other departments may offer a more comprehensive understanding of how data visualization affects performance at various levels of governance and industry sectors. So in the spirit of continuous improvement, I've decided to have this study because I am deeply engaged and passionate in any development in the strategic planning and design aspects of our infrastructure projects in our office. So please let me share one of our activities as shown in the slide. We have recently conducted training for Microsoft 365, which is an advanced tool in data visualization. So with my initiative, we requested licenses from the central office and training for the regional planning and design office. Thank you, everyone, and I appreciate your attention and your time for listening. And thank you so much for this opportunity.